All right. What is up? How it's going? What are you doing on this beautiful Sunday afternoon? Let me see real quick. All right, I think everything is working perfectly fine because yesterday I had a big issue. I made a big mistake. And let's give us some more time to relax a little bit. All right. So yesterday we created our matching engine, our order books, and that's actually completely done. Let's say for 90% done. Today, we are going to create our API. So basically what we're gonna build is a crypto exchange completely from scratch, where the end goal is to trade real Ethereum tokens, of course, tokens from our own private Ethereum blockchain that we're gonna set up with Ganesh or Hardhat or something else. And we are gonna trade these tokens over our own custom exchange with a JSON API. And that's exactly what we're gonna build today. We are gonna build an API so we can interact with our own exchange, with our own matching engine order book from the front end. It is what it is. It's that simple. It's that easy. It's that easy. Let's give us 5 more minutes. All right. Excuse me. So, the first thing we are gonna do is we are gonna move these files into its own folder. Why? Because otherwise they will clusterfuck our other code up. The Crypto King is live. Terry, that's true. The Crypto King is live. I'm so glad you noticed. I'm so glad you're here. Where were you yesterday? And where were you the day before? That's the question. Let that sink in. All right. So let's make a new folder. We call this order book. And we're gonna move these 2 files inside of it. What's going on? And we're gonna change this order book and the test the same thing. All right, is this thing working? That's the question. It is, of course. All right, so what we're gonna do? Normally I would not install so many packages, but for the sake of making it ourselves so simple as possible, we are gonna install a package to create our own convenient HTTP server. And I'm distracted because there's a lot of things going on in the background. So we're gonna install this package, labstack echo. It's a simple HTTP server, it's quick, it's easy, and that's all we need to install. We're gonna use this, we're gonna copy it and see if it's all gonna work. So I think it's something like, it's a long time I used this. Echo new, and it should be v4. And then we're gonna say, even start at a port 3000, because that's always a good setting point. It's always a good port, 3000. It's the best It's a default choice. All right, that's that. Let me quickly check if this is working. It is. Cool, so what we're gonna do, we're gonna make an API. So what do we need? We need a handler. So we can place an order. And we also need a handler so we can fetch the order book, the state of the order book. That's important. So that's what we're gonna do. So let's start with placing an order. Let's call this handle place order. And that's gonna be, I think it's gonna be C echo context. Not quite sure. Turns an error. And then we could do something like return C JSON status and some garbage. All right. Just for the sake to test this, we're gonna open up Postman. Man, this is this is confusing. It's a long time I used this thing. What the hell's going on? How does this thing work? All right. So I have something installed on my desktop. It's called Postman Agent. So if I click on it, it opens up the same shit. All right, we got it. Okay. I already tested some shenanigans before just to make things smoothly. So what we're gonna do is we're gonna, first of all, I'm gonna create this handler. It's gonna be get, gonna be post order, and then we're gonna say it's gonna be handle place order, right? Something like this. All right. Make run. And then we're gonna try to send this, and it returns as garbage. Exactly, it's working fine. So now we can actually do our good stuff. So we know that we need to place an order, so we need the order book. So we also need some kind of a structure that we can use to place our order books inside of it. And by order books, I mean, it could be that we are going to trade, for example, Ethereum tokens, BTC tokens. Probably not BTC because we're going to use our own Ethereum private chain. So it could be some other ERC20 token. But we need to have multiple order books. So how are we going to do this? And we could do something like exchange. It's going to be a struct where we're going to say we're going to have order books, which is a map of ticker. A ticker is basically a symbol of our market, or we can say it's going to be a market itself. Why not? Let's call it market. And that's going to hold a pointer to an order book, which we created ourselves. Order book. All right. Excuse me. So, market. We could say something like market is going to be a string. And then we could say, make some constants where we say market eat is a market, and it's going to be eat. Ticket eat, right? So we could say market ticker, whatever. We're going to call it market. Makes sense. What is this crosshair doing? Yeah. All right. So Next thing, let's make a constructor. New exchange. This will return an exchange, right? I'm gonna return a pointer to an exchange. Order books. There's gonna be a map of market. Order book and order book. Something like this. Let me quickly check the health of the stream real quick. Can somebody confirm that the audio, the sound is okay? That would be nice. That would be so nice. So I know I'm doing a good job because yesterday I had some technical shenanigans. All right. So, okay. The first thing we need to do, so we create a web server, that's all good. The next thing we're gonna do is create our exchange, which is new exchange. And instead of creating this handler, because we need to have a way in our handler to fetch the order book based on the market we give it. So what we're gonna do is instead of making this handle place order a standalone, you're gonna say it's gonna be from the exchange. All right. Like this. Sound is perfect. Thanks, Teddy. You are the real chat. Thank you so much. Yeah. So we have this exchange. Then we're going to say handle the order. And that's exactly what we need. So we're gonna make a type. We're gonna call it place order request. And it's gonna have, so we need to request so we can actually marshal and unmarshal it, decode, encode it from and to JSON. And it's basically the API. That's the thing. People are that's the data that the people, somebody, we don't know, we don't care, is gonna send over the API. So let's say we need a type. It's gonna be an order type, which doesn't exist yet. We need to say if it's a bit or an ask. So we're gonna use a bool, because we can place bits and we can place asks. We need a size, float 64. We also need a price in case we make a limit order. So this order type is gonna be a limit or market, right? So bit, size, price. I think that's it. So what's going to happen is I'm going to say place order data. It's going to be this place order request. Then we're going to say if there's an error, JSON, new decoder. We're going to decode the request body. Decode. Man, I'm I'm literally too good at this thing. We're gonna decode. We're gonna place the memory of this place order data. And if it is an error, we're gonna return the error. And what the hell is going on? Let's make this order type real quick, because order type, it's going to be a string. We're going to do the same thing, and we're going to group this a little bit up. I'm going to say market order, and order type is going to be a market. The same thing with limit. Limit orders. It's going to be a limit. All right. Like this. Wait, so the next thing, wait, we forgot something very important. We need to have this market here. Because if we want to place an order, we need to tell the exchange what kind of market we want to place the order for. Are we placing Ethereums? Do we want to buy Ethereums? Do we want to sell Ethereums? Do we want to sell Shiba Inus? Or something else? We don't know. So we need to specify the market. So then we could say that the order book man, wait, let me just quickly, and today it's water, yesterday was Coca-Cola, today is water. Need to keep hydrated. So we need to fetch the order book. So how we can do that is exchange order books. First of all, let's say something like market is going to be a market of place order data at market. Why? Because place order data at market is a string, so we need to convert that to a market type. And then we can put the market inside of this thing. And then okay, then we have an order book, and then we can say place limit order, and that's an API that we created yesterday. That's our core matching engine functionality from the previous stream. We could say place limit order, but first we need an order. It's going to be order book, new order. And we need to specify if this order is an ask or a bid. So we could say place order data in bid. And now we need to specify a size, which is going to be the place order data size, right? And then if you want to place a limit order, we need to specify the price, because the limit order, like I mentioned yesterday, a limit order, previous stream, a limit order is a bucket that holds different orders that are sitting at the same price level, but with different sizes from different people, right? That's a limit. So we need to specify the price, and we're going to say it's going to be the place order price, and then we're going to say the order, right? I'm going to place it. And for now, we're going to assume that it's going to work. So we're going to say something like map string any. What the hell's going on? Order placed. Easy as that. And of course, we need to do something like, because right now the order book is empty, right? If we just do this, we're going to have an exchange struct with order books with no books. So we need to make one. So I'm going to say order books is going to be this bad boy. What's going on? Order books, and then we could say order books BDC, no, eat, market, market eat is going to be order book, new order book. Voila. Let's restart this whole shenanigans. Open up this thing, And oh my God, this is still in my history. Isn't that amazing? So what we're gonna do, we're gonna place a limit order, a bit. We're gonna say size is gonna be 10. The price level is gonna be 10K, 10K euro, 10K dollar, 10K rupees. It doesn't matter. The type is gonna be a limit, and we forgot the market. We're gonna say yo is gonna be ETH. All right, and I think it's gonna be some issues, but that's normal because we are engineers, and that's the thing we do. We're making issues so we can solve them. We're getting paid, and we do it again. Easy. All right. Order placed. The question rather is it really placed? That's another thing. So the order is placed, and we're gonna make this much better. Trust me. Trust me. I am no savage boy. We're gonna make this perfect. But first, I wanna have something so we can actually see inside our order book, inside our exchange. I wanna see what's inside of it so we can debug it more efficiently. So the next thing we're gonna do is we're gonna make some GET requests. We're gonna say books or book, and it's gonna be a market handle get book, maybe handle get book or get market. I don't know. It doesn't matter. It doesn't matter. So exchange handle get book echo context. Oh my goodness. Error. All right. So the first thing we need to do is get the market, because we're gonna fetch the book for a specific market. In our case right now, only Ethereum. So the market is going to be, I think it's per RAM. Yeah, I think it's per RAM. Market. And we could do something like market. We're going to cast it to a market type. And we're going to do the same shenanigans again. Order books, market. And we could check it, right? We could do something like if okay, we could do something like JSON 200, or no, HTTP status bad request, and then say something like message market not found, something like that. What's going on? What the hell is this? Missing key in my pluggable. Making mistakes. All right. So at this point we have the order book. Then we're gonna say, we're gonna loop what's going on with this order book thing. Oh yeah. So let's say for all the asks, OB asks range, man. All right, so what are we gonna do? We're gonna dump all the asks sitting at the books and all the bits sitting at the books. And we're also gonna add some extra volume and some other cool stuff to it. So we actually can see if we place an order, yes or no. So the first thing we need to do is loop through all the asks. Now you will see. So it's gonna make sense in just a bit. Just do nil from now. So we loop it through all the asks, then we're gonna loop through all the limits, I guess. There are the limits. And these are the orders. Limit orders, man, I need to think. It's... Yes, like this. Okay. So we're gonna loop, we're gonna fetch the asks, which are a bunch of limits, bunch of limit price orders. We're gonna loop through all the limits, then we're gonna loop through each order inside of this bucket, and we're gonna put them into a convenient structure so we can actually dump that to our screen. That's what we're gonna do. So that could be something like order book data struct. We're gonna have asks. Which is gonna be a slice of order, I guess. We're gonna do the same thing with bits. So what does an order have? We're gonna say it's gonna have a price. Because market orders don't have a price, but the market orders are never in the books, so we don't care. So we could say, we could call this a limit order if we really want to, but order, it's fine, it's fine. We know what is going on, we know what's up. The price is gonna be a float, 64. We're gonna have a size, float 64. I'm gonna say if it's a bit, yes or no. Maybe we could add a timestamp. It's going to be an N64. Why? Because it's Unix Nano. If you go open up the order book, you could see the order inside of the order book. It's a we could use the same order. I'm not gonna lie. We could use the same type, but so you see, it has a timestamp, and that's exactly what we're going to use in this order. It's going to be our JSON representation, and the other order inside the order book is going to be our business logic order. And for the sake of now, we're just going to create our own order, so we don't need to hassle with the pointer that limit has. So we're gonna loop through all these things here. Then we're gonna say order book data the asks point order, yes. Same with the bits. Like this. And then we could do something like order book data asks. I'm gonna append them. An order. And maybe we could do something like this. Something like this, right? So we could do something neat. I'm gonna say O. What else going on? Invalid type. Why? God damn it. I'm not on point. Need to warm up still. Like this, and then you could say there's a price, size, to limit. We need, if it's a bit, gonna be the same thing, bit, then timestamp. So you see, we do a duplication. I know. We are basically duplicating all the values from our other order struct to this order struct. I know. But we're gonna first make it work, then we're gonna make it better, and then we're gonna make it fast. That's the circle of success. Don't over-engineer your code instantly. It will give you a lot of headaches. So, we have this order book data. What is going on with... Oh, I see. All right. Let me quick. What the hell is going on with this guy? All right. And what we're gonna do then is basically we're gonna say JSON 200, or to be perfect, status OK, like this, and we're going to return the order book data. Hopefully it's all working. It should be. So it's only the ask. We also need to do the bits, I know, but first we're going to check if it's working for the asks. Make run. All right, so let's open up this Postman. First of all, we're going to post a new order. Market eat. Sultan, I do learn so much from the Crypto King. Not quite sure if I'm the Crypto King, but if you want to call me like that, why not? I'll take it. So we're going to place this bit, and we're going to see what's going on. So we're going to send this, it's all good. And then we're going to get books, book, eat. Please. All right, so we are getting something back, but there is nothing in it. So there is something wrong, right? But at least we're getting somewhere. Oh, wait, I know maybe why. I know why. And this Postman, I don't know what's going on. Look at this. What is going on? So, post body. So, yeah, but false, right? So I think maybe that's the problem. So the order is placed. All right, so it's working, fine. Because we didn't implement the bits, right? So we can see we placed an ask, size is 10. Of course, it's the bit is false because it's an ask, and the timestamp is Unix Nano, and the price at 10K. So that's working. That's good. So we're going to do the same thing, exact same thing. We're going to just do this, this, and then that. And the only thing we need to do is change this to bits, right? Bits. And it's gonna be much interested. That's not even a word. Exciting. It's gonna be more exciting once we have these other things in, so we can actually place orders and see what's going on, we're going to fill them and we're going to see how an exchange actually works under the hood. So bits, I need to double check, right? So we range for the bits, then we do bits, we append to the bits, it's good. So right now, let's do it again. Of course, if we get it now, everything is empty. We're gonna post or place a limit order. And I hope you can see this clearly. So we're gonna place an ask, then let's do this. Then we're gonna place a bid. We're gonna place 20 BTC, 20 ETH in this case, at price level 8K, right? Boom. And now, if everything is perfectly fine, we should see asks and bids, and it is. Look at this. So we have asks and we have bids. That's amazing. So let me post real quick another one. So at 8K, let's say we post at 9K. Size 2. Why not? All right, that's working. So we have 2 bits sitting in our order book. Size 2 at price level 9,000, and size 20 ETH at price 8K. So the next thing we need to do is now basically a limit order is a way to provide liquidity to an exchange, right? That's basically the most simplification of an explanation I can give you. A limit order is a way to provide liquidity. Market makers do this all the time, right? So they place asks, they place bids. So we can buy Ethereum or Bitcoins or Rupus at all times for any size we want, right? So we have our limit orders working, so we can provide liquidity. The next thing we need to do is make sure that we can also place market orders, and then we can see them being filled on the screen. That would be nice. So place order. So we're going to use the same API, right? We're going to use the same API. We're going to just change the type. What the hell is going on here? We're just going to change the type. YouTube is not receiving enough video to maintain smooth streaming. What the hell is going on? I really hope the quality is okay. Normally I have the same settings as yesterday. So if something is wrong, let me know. Let me know. Anyway, so market order. We're going to use the same API handler. But I think we could do something like if the place order data, and I'm confused. If the place order data type is a limit, okay, so like limit order like this, I guess we could say this and return something like this. And if it's not, we could actually I am really new in blockchain and not really explore it. Is a crypto exchange available in Python and JavaScript? A crypto exchange could be available in every language you want, right? A crypto exchange is basically a piece of software that exists out about in a couple of modules, right? So you have the backend, could be written in any kind of language you want. Most of the time, it's a very fast language, a typed language. And you have also a front end that's probably being created in TypeScript or JavaScript. So there are a couple of languages, a couple of modules an exchange is being made of. And if you follow this series, you will see, right? So our backend is going to be, it's like we do right now, is going to be written in Go. And the front end is going to be written in JavaScript or TypeScript, probably TypeScript. And yeah, that's it. I hope this answers your question. So this should be a market order. If place order types market order, then we do place market order. Market order. And that's actually just the order, because a market order is always being executed against the best price on the exchange. So we don't need to give it a price. And a market order, like we mentioned in the previous stream, will return us some matches, right? Because we are always sure that if we place a market order, it's going to get filled by the market. So it will return matches. So we're going to catch these matches right here. And we're going to say something like, just for now, for debugging purposes, we could say len matches, right? Something like that. And we return null in this case. All right. That should work, I guess. Let me quickly check, because I'm very concerned that I'm losing because I'm doing this stream, but I'm going to use this video also on my YouTube. So if this video is broken by some kind of garbage quality, then I'm screwed and I need to do it all over again. Now, what is going on? All right, let me see. Excellent connection, so it's going to be good. All right, so let's see what's going on. Let's restart this thing real quick. Make run. Open up as postman. Let's post a couple of liquidity real quick. So let's say we're going to post 10 Ethereums. As a buy order. And what I'm going to do is we're going to fetch the books. What the hell is going on? We're going to fetch the books, and we're going to have two orders because I double clicked it. We have 2 bits. So now we're going to sell. So our people are on the exchange willing to buy, and we are going to sell. So we're going to make a post. And that should be a market. Let's say we do 1. The price doesn't matter. We can delete this for our market. We can keep it. We can delete it. Doesn't matter. And let's send this out. And we have an error. The first error of the day. Always good. Always good. So what's going on? Not enough volume. All right. And why is that? I know why. Or don't I? Did we place a buy order? Am I so stupid? So we're going to say false, and there's going to be a market. Once again, we're going to say 1. We're going to execute it. And this postman, man, this needs to be false. 1, market E, let's go. Yes, matches 1. That's good. So now, damn it. Now we're going to fetch again the books. Perfect. You see? So what happens is we sold 1 ETH as a market order, and it's matched by this order because that was 10, size 10, and now it's 9. So this is working just fine. Nice. The next thing we're going to do is we're going to add some more information to the exchange, because I want to know if I query the order book, I want to know how much total volume is there for the asks, how much total volume is there on the bids. And we already had this nice API implementation we did yesterday. So it's going to be a super easy walk in the park. So we could say total bid volume is a float 64. I'm going to say total ask volume. And then we do total bid volume, total ask volume. You could say OB bid total volume and OB ask total volume. Boom. What's going on? Unknown field. All right. So let's test this real quick. The first thing we need to do is give it some liquidity. So let's say I'm going to make a limit. I need a price. Price is going to be 10K. And let's say size is going to be 10. So I'm going to post this order. Then I'm going to fetch the books. And it's going to tell me that the total ask volume is 10 because it is 10, right? So that's good. So let's post another one. Let's say we place an order of size 20 at level 9, level 9K. Boom. We're going to fetch the books once again. And now we can see we have an order at price at the limit 9,000, 9K. And we have an order at 10K, at the limit 10K, different sizes. And the total ask volume is 30 because 20 and 10 is 30. Quick math. So that's all working fine. That's good. So what I'm going to do is I'm going to take a quick toilet break. 45 seconds. I'm going to come back. And we are going to do some other nice stuff, right? Because we did some nasty things here and there. We're going to clean it up. And we're going to see what else we need for our exchange. I'll be right back. And I have no waiting screen. Be right back. Be right back. Give me 40 seconds. All right, I'm back once again. So, what did we have? We can place a limit orders, and we can place a market order. We can fill it. What do we need? We need a cancel order. So we need to find a way to cancel orders. It's pretty important, especially if you are going to build. We're also going to build market maker algorithms later on. It's not for this series, but it could be nice. It would be nice if we use our own exchange to provide liquidity to, due to our market maker algorithms. And they need to have a cancel order. It's important because what our guys are doing is they place orders at different kind of levels. And if the market is not going in a certain direction, they need to cancel other orders. Otherwise, they keep sitting in the books, which basically means lost liquidity, right? It's liquidity that's not available because it's sitting at a certain limit and they cannot use it at other limits, at other price levels. So let's make a new API. Exchange. Man, what the hell's going on? Cancel order maybe. Like this. I'm gonna have C, a context, an error. Yeah, cancel order. That's actually an issue. Why? Because if you want to cancel an order, we have this API, right? So if you go to order book, let me see, cancel order. We have this cancel order somewhere. What else is going on? Cancel order. Yeah, right here. So we can cancel an order and it works. We tested this in our previous stream, but how are we going? The way we do it right here is by giving it the order itself. We are giving it the pointer to the order so we know which order we need to delete. But the problem is, if we are going to do this over JSON, over our API, we will need to have an idea, an order ID, so we can look it up. So that's what we need to do. So we will go to our order here and say ID. And we could use a UUID or something, but we could use an int64, I guess, and then we could say, if we make a new order, rent, not quite sure what it was, int n. Let's make it big enough, just for now, just for the sake of testing this. N64, I guess. So let me quickly check if this is working. We can test that on our own exchange. Let's post one. Okay, let's make one. Let's make a limit order. Let's get the books. The ID is 0. And that's not good. And why is that? Man, so many code we already written. That's crazy. All right. I thought this function would return a random number between this int returns an int, a non-negative pseudo-random number in the half-open interval from the default source. Okay. So what the hell is going on then? So I'm gonna keep placing a bunch of orders to see what's going on with this random number. Okay, we are fucked. What's going on? Oh, I think I know. I made a big mistake. Where am I mapping these orders? That should do the trick. So let's create some couple orders to see what's going on. All right, we're getting ideas. That's amazing. So if we want to cancel an order, we're going to basically cancel it by ID. I think that's a good idea. ID. So cancel order. We're going to say something like a get should do the trick. You're going to say cancel, or we could do delete, but if it doesn't matter. We're going to say cancel just for now. Or maybe we're going to make it. Maybe we do this. Delete, and we could use the same how does it ID, something like this, cancel order, and then we could say that the ID of the order is the params ID. Why is this? I think it's param. All right. So we have the ID. So then, how the fuck do we know if the order is sitting in the bits or in the asks? That's a good question. Normally what we should do is store each order in some kind of an order in a database or in a memory table, so we can easily look up these orders. That's something we could do. Because right now we should loop through through all the asks and check the orders there, then loop through all the bits and check the orders there. And that's going to be a very inefficient way of doing things. So let me quickly think about this. Oh man. And the sun is shining outside. Nonetheless, it's always a good idea to come to the stream or watch this video later on, I don't know, to absorb all the information I am providing you. All right. So, deleting an order from the API. Canceling an order from the API. We could also say, for example, that if you want to delete an order, we specify if it's a bit or not, so we know in which table we need to look. But that's a bit of, I don't know. That's weird. That's weird. You know what? That's what we're gonna do. That's exactly what we're gonna do. I will think about this, and you can do this as a homework. Think about this, how we can make this more efficient. And probably we need to save these things, but that will take a lot of time to implement, especially right now. So what we could do is we could say cancel order request. Right? And you could say, for example, bitbool ID N64. What's going on? Cancel order request. It's going to be a cancel order request, and then we're going to say JSON new decoder see request body body decode this cancel order request, check the error. We could do something like we could yank some other error, we spit it out, something like nowhere. That doesn't matter, we do it anyway. What's going on? Okay, so I'm just gonna do this, fuck it, easy. So we decode this request, right? And we're going to say if the cancel order request is a bit, then we could say something like 4. The problem also is that we need to know if we want to cancel an order on which market that order is. And that's a really bad API, right? If I want to cancel an order, then I need to specify it's ETH and it's a bit. Normally, I just want to say cancel my order and this is the ID and do whatever, just make it happen, right? That's exactly what it is. So I think, because I really think that canceling an order is pretty important for an exchange. It could be, you could think it's pretty minor. We don't need cancel, but we do, especially if we are going to implement these market maker algorithms. It's super important, super important. It is. And I don't think we can cover this in this stream, because this episode is already is already over an hour. So your brains will already be cooked out, overcooked, something like that. And I'm thinking actually how I can make this the most efficient. Cancel request. It's not going to happen like this. It's not going to happen like this. What we could do to make it work today is basically just do some very nasty stuff. For example, I could say the idea is the param ID, and then I'm looping. I'm just gonna fetch the order book. We don't give a shit what market it is. We're gonna loop through all markets. In this case, it's only BTC. So we're gonna assume, for now, market ETH, I mean. So we're gonna make a new order. We're gonna make a new order. We're not gonna make a new order. Damn. We are gonna fetch the book and then we're gonna say delete. What's going on? Cancel order. But first of all, limit range will be asks you see how deep you need to go, right, to find these things. That's why keeping a separate map, struct, whatever, array, key value of these orders would be very nice. But for now, we're just gonna fix it like this. So we're gonna range through all the asks, we're gonna range through all the orders. Like this. And then we're gonna say if the order ID equals the ID OB cancel order, the order. And what is going on? ID and string cannot compare. What the hell is going on? Ah, I see. Of course, because if you're fetching a param, it's always going to be a string. So you could say ID string is string conf, I think. Yes, atoy. Atoy. A to A. Not quite sure. This is on top of my head. I could be wrong. What else going on? I think N64. All right. So we're going to loop through the asks. This is legit garbage code, right? I know. But just to make it work, for now, we're going to loop through all these shenanigans. We're going to cancel the order. And you could say, this is actually so bad, but it is what it is. Order cancelled is false. And in this case, we're going to say order cancelled is true. I have no clue, man. This should work. So we're going to return order cancelled. All right. The question is this gonna work? So we loop through all the asks, we loop through all the orders of the ask, we're gonna check, we're gonna compare if the order is the same, the ID is the same. If it's the same, we're gonna cancel the order. We're gonna say that the order is cancelled. So we don't need to loop. We're gonna break. The problem is there are two. You know what I'm gonna do? I'm gonna do this. Next episode, we're gonna for sure clean this up, because because this is basically, you get fired by this code. Literally fired. This is code. If you write this piece of code, you're gonna get fired. But for the sake, I wanna see if it works. So, yeah, it should work. I don't know. All right, I'm so curious. Make, run. All right, distracted once again. So what we're gonna do is we're gonna post a limit order. And then we're gonna cancel it. So we're gonna copy this ID. I'm gonna copy this ID. We're gonna make a new GET request. It's a delete, I think, where we say order with the ID. The question is it cancelled, yes or no? We did it. Not the best, I know, it was not the best. I'm 100% agree, I 100% agree. But sometimes you need to solve the problems with the tools at hand, right? So it works. So what we definitely need to do is we need to clear this up, because we need to find a way. We need to find a way to store the orders inside, somewhere in order book. Somewhere here. We need to find a way to store these orders somewhere in a key value with ID and then the order, and then we could always track these orders. And if they are filled, we just delete them, right? Each time we fill an order, we can check the ID, delete it, but then we have a nice mapping of IDs with orders, and then we don't need to check if it's an ask, and we don't need to check what kind of market it is. We don't care. We can just cancel it, right? We can fetch the order and make it disappear. All right. So I think this is basically a very good episode for today. We have the opportunity to place orders with the API. We have the opportunity to place market orders with the API. So we can make the market with limit orders. We can provide liquidity with our limit orders. We can buy and sell our own tokens. We can buy and sell tokens with a market order. We can cancel the orders. The next episode, episode 4 of this series, where we create a complete crypto from scratch, crypto exchange from scratch, we are going to hook it up with, what we need to do is basically these matches. I will show you. So we have something what's called matches. Let's go to, what's going on? Main. So if we place a market order, we have something called matches, right? Here. So we don't do anything with these matches, so we need them, because that's where the magic will happen. That's where we know exactly what we need to do. So we're gonna make the orders. We're gonna keep track of the orders, because it's important, because in these matches there will be orders, and we need to track the ID also, because we need to know who has created the order, so we can fetch his Ethereum address and we can send them, or subtract his Ethereums from him. And that's what we're going to do in the next episode. It's going to be a very interesting one. Maybe the most interesting one of all, because it's actually where we're going to connect the dots. Connecting the dots, indeed. All right. you know what's going on. I'm gonna close the stream. If you like what you see, if you like this series I'm bringing you, the content I'm bringing you, the value I am providing to you, please consider subscribing. Give me a like, give me a thumbs up, and I'll see you. If you have questions, of course, leave them in a comment. I will always answer them personally. And I'll see you in the next video. Thanks for watching. See you. Have a nice Sunday. Bye-bye.